In this slide, we will see about the second generation case tools. Early case tools, what we call first generation case, were revolutionary for their time, but they were quite limited. They primarily focused on automating tasks like diagramming and generating documentation. They helped a lot, but they were still largely passive tools. However, the field has evolved significantly. The second wave of tools, known as second generation case, introduced much more advanced capabilities. They moved beyond simple automation to a new level of intelligent support. Here are the key characteristics that define these more advanced tools. The first one is intelligent code generation. First generation tools could generate code skeletons. Second generation tools can generate fully functional working code. For example, a tool like Visual Paradigm can take your database ER diagram and automatically create a complete database schema and the necessary SQL scripts to build it. This saves an enormous amount of time and eliminates a major source of human error. The next characteristics is round-trip engineering. This is a game-changing feature. It means that the design and the code are always synchronized. If you make a change in a design diagram, the tool automatically updates the corresponding code. And just as importantly, if you change the code, the tool updates the design diagram. This ensures that the documentation and the implementation never drift apart, solving a common and frustrating problem in software development. Next comes the repository-based integration. Unlike older tools that operated in isolation, second-generation case tools are built around the shared central repository. This ensures that every part of the project, from requirements to design, code and test cases, is linked and consistent. If a requirement changes, the impact can be automatically traced and managed throughout the entire project. Next characteristics is support for modern methodologies. Finally, these tools are built to support modern development practices. They are designed to handle the complexities of object-oriented development and can be integrated into agile methodologies, making them more relevant and useful for today's software teams. Examples for these advanced tools include IBM Rational Suite, Oracle Designer, and Visual Paradigm. These tools represent a major leap forward, transforming case from a helpful tool into a truly integrated and intelligent development environment. Hope you all understand this concept. We'll move on to the next phase. In this slide, we will see about the architecture of a case environment. Now that we know what makes a case tool effective, let's explore how a full case environment is actually structured. It's built in a layered architecture that ensures all the different tools and people can work together seamlessly. Think of it like a modern office building. Each floor has a different function, but they are all connected by the elevators and stairwells. First layer is the presentation layer. This is the top layer, what the user sees and interacts with. It is the user interface of the case tool. For a developer, this might be the dashboard of their integrated development environment, which is IDE, like Visual Studio. For a project manager, it could be the task board in a tool like Jira. This layer is all about making the tools accessible and easy to use. Next is the application layer. This is the heart of the system. This layer contains all the integrated case tools themselves. This is where the modeling tools for diagrams, the code editors, the testing frameworks, and the report generators reside. This layer processes all the logic and performs the task that the user requests. Next is the repository layer. This is the foundation of the architecture. The repository is the centralized shared database where all the project artifacts are stored. Everything from the initial requirements and the design diagrams to the final source code and the test results lives here. For example, a tools like Rational Suite uses a shared repository to ensure that all project data is consistent and up to date. Next is the integration layer. This layer acts as the glue that connects everything. It's the layer of a middleware and messaging services that allows the different tools and layers to communicate and share data smoothly. It uses standard formats like XML or JSON to make sure that a design change in one tool can be instantly and correctly communicated to the code generation tool and so on. This multi-layered architecture ensures that everyone on the team, from business analysts to designers, developers and testers, can collaborate seamlessly and work on a single source of truth for the entire project. We'll move on to the next slide. Now that we have seen how a case environment is structured, let's summarize the key advantages and limitations of using these tools in a real-world setting. The advantages are high productivity, improved quality, better documentation, and enhanced team collaboration. Let's look deeper into this. High productivity. The most significant advantage is a dramatic increase in productivity. By automating time-consuming tasks like code generation and documentation, case tools allow developers to focus on more complex creative problem solving. A single UML diagram can generate thousands of lines of code in seconds, a task that would take a developer hours and even days to complete manually. The next advantage is improved quality. By enforcing standardized processes and automated repetitive tasks, case tools significantly reduce the risk of human error. This leads to higher quality software that is more reliable and maintainable. Next advantage is better documentation. Case tools automatically generate reports and design documents directly from the project's data. This ensures that the documentation is always consistent and up to date with the latest version of the code and design. Next advantage is enhanced team collaboration. With a central repository, multiple developers can work on the same project simultaneously without conflicts. Everyone on the team, from designers to testers, is working with the same most current version of the project's data. Next, we will see about the limitations. The limitations are high cost, steep learning curve, integration complexity. First limitation is high cost. Case tools can be very expensive to purchase and maintain. For a small startup or a project with a limited budget, a high-end suite like IBM Rational might be prohibitively costly, making free or open source alternatives a more viable option. The next is steep learning curve. These are sophisticated tools. They require a significant amount of training and skill to be used effectively. An untrained team might struggle to fully utilize the tool's capabilities, leading to frustration and inefficiency. Next limitation is integration complexity. Integrating a new case environment with an existing legacy system can be a complex and a challenging task. It often requires significant customization and can introduce new compatibility issues. In summary, while case tools offer powerful benefits in terms of efficiency and quality, they are not a one-size-fits-all solution. The decision to use them depends heavily on the project's scale, budget, and the team's expertise. We'll move on to the next slide. Let's bring all the components to life with some real-world examples. Many of you have likely used these tools without even realizing they fall under the umbrella of case. First comes the project management. For planning and tracking, project managers rely on tools like Microsoft Project to manage schedules and resources. Teams that follow agile methodologies use tools like Jira to track user stories and tasks. Next is requirement analysis. When gathering detailed requirements for complex systems, engineers use tools like IBM Doors to capture, manage, and trace all the specifications. This ensures every project detail is accounted for. Next is the design and modeling. For creating system blueprints, tools like Rational Rose and Enterprise Architect are used to create UML and other design diagrams, providing a visual representation of the system's architecture. Next is the coding phase. For writing and debugging code, developers use IDEs like Visual Studio and Eclipse. These powerful lowercase tools provide a single interface for writing code, debugging, and compiling it. For testing, especially for automation testing, is a core component of modern software quality. For web applications, Selenium is a powerful framework for running automated tests in a browser. For unit testing in Java, developers use JUnit to ensure individual code components work correctly. Next is the configuration management. To manage changes to the source code, teams use version control systems like JIT or Subversion. These tools keep a complete history of the project, making it easy to track changes, collaborate, and revert to previous versions if needed. If you have ever used GitHub to manage your source code, you have already used a sophisticated lowercase tool. As you can see, case isn't just a theoretical concept. It's a collection of tools you will use every day in your career to build, test, and manage software more efficiently. I'll move on to the next slide. As we come to the end of this session, to summarize, we have covered a lot today. CASE, Computer-Aided Software Engineering, is a powerful environment that uses a suite of tools to automate and integrate the entire software development lifecycle. We learned that CASE is not just about coding. It supports every stage of a project, from the initial phase of requirement analysis all the way to design, coding, testing, and maintenance. This holistic approach is what makes it so effective. We also looked at the evolution of these tools from the basic first generation tools to the more advanced second generation CASE tools. These newer tools emphasize deep integration, intelligent automation, and features like round-trip engineering, making them essential for managing the sheer size and complexity of modern software projects. As software continues to grow in scale, CASE tools are no longer a luxury, they are a necessity. They ensure that projects are delivered faster, with better quality, and at a lower cost. In our next session, we will put all this theory into practice. I will provide a live demonstration of a CASE tool so you can see firsthand how these features work and how they can transfer the way you build software. Thank you.